Hello, Algebra. Hope Chapter 7, the review assignment went well for you. This is 8.5. This is, I believe, the only lesson we're doing Chapter 8. Just a little bit touching on it. It deals with the quadratics that we've been having and the graphs of them a lot more. So we're skipping a lot of the graphing. This is the only lesson we're going to do out of it. If you are bored, you need something else to do, I encourage you to use the big ideas lessons. Go back and kind of look at 8.1 through 8.4, other sections of Chapter 8. See if you can figure it out. Those who take Algebra 2, this will be something that's hit really early in the year. So having a basic understanding of it would be very helpful. Again, if you are in that boat, when we get there, I'll understand, I'll remember that this is what happened this year, and we'll have to do a little bit more teaching. But this is something, those who take Algebra 2, this is a big part of that class, so I wanted to give you a little bit introduction to it. Okay. So the standard form for a quadratic is this right here, ax squared plus bx plus c, and we've seen that a lot over the last couple lessons. We're going to look at what they call the intercept form, which is a times x minus p times x minus q. P and q, they represent the values of the x-intercepts. So P and Q are the letters that they use to represent where a graph crosses the x-axis. That's the x-intercept, where the graph crosses the x-axis. Okay? So each one of these, if it's anything like this, it's going to be this graph, which we call a parabola. And if you're looking for an equation of this, you notice here, these are your x-intercepts right there and right there. So the x-intercept is 1 and 2. So the p's and q's, p would equal 1, q would equal 2. So you'd get f of x equals x minus 1 times x minus 2. The minus signs are built into the formula. So if p is positive, it's going to be x minus. If p would be negative, it would be minus a negative, which makes it a plus sign in there. So, and if you FOIL this out, you're going to get the standard form for that. So you take x squared minus 2x minus 1x plus 2, so you get x squared minus 3x plus 2. And we'll review this later on. So we have a standard form for an equation, quadratic equation. We have the intercept form, because that tells you the x-intercepts right away. Now the number that's in front, you notice this does not have anything, so it's positive. This has a negative sign. So the negative sign is for when it opens down, what we say opens down. So this one is going to open up. And it comes from this part right here, and it's positive. It's positive, so it's opening up. This is negative, so it's opening down. So if you're looking at this one here, it has the same x-intercepts of 1 and 2, but it's opening down. It's going down. So that function would be f of x equals negative x minus 1 times x minus 2. Now you'd still multiply, double distribute, FOIL, box method, whatever you want with that. So you get negative parenthesis x squared minus 3x plus 2. Now you can distribute the negative, negative x squared plus 3x minus 2. Okay, so now you could get your standard form and you have your intercept form. So intercept form, FOIL those two, and then distribute what's on the outside. Okay, so this is 0, and this is 1, 2, 3. It's going up, so I can have f of x equals x minus 0 times x minus 3. Well, x minus 0 is just x. X times x minus 3, so that'd be x squared minus 3x, and it just stays like that. That one does not have a constant. This constant that's at the back, that is always going to be your y-intercept, because when x is 0, those cancel off, that's all you're left with. So notice the y-intercept here is 2, the y-intercept here is negative 2. So the c value, the one at the end, should always be the y-intercept when you're graphing this. Okay, opening up, this is a negative 3, this is a 0. So f of x equals x minus 0 again, times x minus a negative 3. So that changes to a plus sign. So we get x times x plus 3, so this one gives us x squared plus 3x. Again, there's no c value, because the c value is 0, we don't write it, and the y-intercept is 0. So these would be the same situations, only you have a negative sign in front. Okay? So I'm going to do that distribution first. I'm going to get negative x squared minus 3x. Whoops. There we go. So I got that x squared plus 3x. It's the same graph, only going down. Negative x squared minus 3x. And this one would be x minus 0 times x minus 3, negative, so that's negative x squared minus 3x. That's negative x squared plus 3x. Okay? Now the other thing with these graphs, another characteristic, is this point that's right up here. That point is called the vertex. Okay? And it is, in this case, it's a maximum. And that's the y value. So the y value is a maximum for this graph. Whereas this one, here's my vertex, and here your y value of this is a minimum. Okay? The domain for every single quadratic graph, x is going to equal all real numbers. Okay? So every single quadratic, you can use any x value. You can plug any x value in. These graphs go forever left and forever right. So even as it's going down, it looks like it's going down pretty steep, and it is. But it is going to go forever left, and it's going to go forever right. Every single one of these quadratic graphs. Forever right and forever left. The range is going to change. So if your graph goes down, your y is less than or equal to your maximum. And if your graph goes up, your y is greater than or equal to your minimum. Okay? So the domain always stays the same. That's the easy one with this. The range is going to change. So if I have this graph here, and it looks like this point is, that's going to be 1.5 and 2. I know it's 1.5. It's the average of these two. We'll cover that later. Okay? But I want the y value. So the range for this function is y is less than or equal to 2. Y is never going to go above it. You're not using 3 and 4 and 5. You're not using those values for y. Y has to be less than or equal to 2. Because it's going down, y is less than or equal to the maximum. Remember, it's the y value of the maximum. This one's going up. It's down here at negative 2. So this is negative 1.5, negative 2. That's my vertex. And it's going up, so y is greater than or equal to negative 2. That would be your range for this one, because it starts, negative 2 is the lowest, and it's going up from there. Okay, so a lot of this is page 265. Hopefully you're already there by now. A lot of this is covered in this definition. This is page 267. Okay, this is intercept form, x minus p and q. Remember, these are the x-intercepts. They have to be the x values of the x-intercepts. The y value should always be 0, so here's your p0 and q0. The axis of symmetry is halfway between them. So this is an axis of symmetry. So this is what reflects this over. So every parabola has an axis of symmetry, and it goes right through the vertex. So the axis of symmetry goes through the vertex. And I'm trying to give you a little bit more information than what you'll need for the assignment, because some of you will need to know this in Algebra 2, have this a little understanding of this. And it is the average of the p and the q. Okay? The graph opens up when a is greater than 0. That is a positive number. And it opens down when a is less than 0. That is a negative number. That is the number that's in front of there. So that's the positive one or negative one. It can be other numbers. Okay, so state the x-intercepts, axis of symmetry, vertex, and domain and range for f of x equals x minus 5 times x plus 4. Now let's change it. Let's go x minus 6. Make things a little bit easier for us. Okay, so x minus 6 times x plus 4. There's our function. So the first thing I want are my x-intercepts. Those are just your zeros. We did this when we were solving these back in chapter 7. And you just want to say, okay, where does x minus 6 equal 0? Well, that's when x equals 6. And where does x plus 4 equal 0? So you minus the 4 over, and that's when x equals negative 4. So your x-intercepts would be 6, 0, and negative 4, 0. Okay. The axis of symmetry. Here's your formula for axis of symmetry. So x equals p plus q divided by 2. So 6 plus negative 4 divided by 2. Well, that is going to be 2 divided by 2, so that equals 1. So x equals 1. It's a vertical line, so it's x equals. So x equals 1, that is a line. It's an equation. Don't just put 1, although your questions already have the x equals, so. Okay. Vertex. Okay, first of all, is this graph opening up or down? So you look in front, it's a positive, so we know it's going up. The vertex. Okay, remember the axis of symmetry goes through the vertex. So we're going to plug in x equals 1 to the equation. So we're doing f of 1. I'm pulling this from up here, right up here. F of 1 equals 1 minus 6 times 1 plus 4. That's negative 5 times 5, which is negative 25. So your vertex is the point 1, negative 25. 1, negative 25. That's where your vertex is. And remember, this graph goes up, so it's going up, down from down here, 1, negative 25. It's going up from there. It's not going to go any lower than that. Okay? So your domain, x equals all reals. That's always going to be the case. And your range, y, since it's going up, y is greater than or equal to your minimum, which is negative 25. Okay? So, where's my mouse? There it is. Again, Desmos can be very helpful. And you just go x minus 6 times x plus 4. Notice there's your zeros, negative 4 and 6. And if you go down to your vertex, 1, negative 25. And if you double distribute, guess what your c values should be? Negative 24. There's your y-intercept. Okay, domain is all real numbers. This goes for ever left and for ever right. And the range is greater than or equal to this negative 25. So graphically, that's what we're looking at with this. Okay, you're going to have a couple questions at the end like this. For any factor x minus n of a polynomial, n is a 0 of the function defined by the polynomial. So this is what we talked about last chapter, where roots, x-intercepts, zeros, solutions, all of those are basically the same thing. So the question is, write a quadratic function in standard form whose graph has x-intercepts of 2 and 8. So when they ask you this question, you are essentially doing what we did here. Okay, they're giving you the 2x values. You just have to write it in intercept form and then multiply it out. We've already worked this out. Okay, so x-intercepts of 2 and 8. So this is your p. P equals 2, q equals 8. P equals 2, p can be 8, q can be 2. It doesn't matter. Don't get hung up on that. Okay, our a is just going to be 1. We're going to assume it's going up. So it's x minus p, so x minus 2, times x minus q, so x minus 8. Now we double distribute. So that'd be x times x minus 8 minus 2 times x minus 8. So that'd be x squared minus 8x minus 2x plus 16. So we get x squared minus 10x plus 16. That is standard form. Again, I would check that on Desmos and make sure your x-intercepts are 2 and 8. Okay, so just graph that in Desmos, and if you have the correct x-intercepts, that should be the correct answer. Okay, has intercepts of negative 4, negative 1. So f of x equals x minus p, so this can be p, this can be q. X minus p, so x minus a negative 4 changes that to an x plus 4. X minus a negative 1 changes that to an x plus 1. So we have x times x plus 1 plus 4 times x plus 1. So x squared plus x plus 4x plus 4. So put those together, x squared plus 5x plus 4. Okay? Those questions, those are the last two on your assignments. Okay? A lot of your front ones, I think the assignments, I hope it goes pretty quick for you. It's just going to be these types of questions here. Find the axis of symmetry, find the x-intercepts and the axis of symmetry of the graph of the function. So they're not asking you to graph it, they're just asking you what are the x-intercepts and what's the axis of symmetry. So we're going to do this first. X-intercepts, we're going to take x plus 2 equals 0 and x minus 4 equals 0. So just like what we did when we were looking for the solutions to the function, we want to know where does it equal 0, where does y equal 0. So x equals negative 2, and the other answer is 4. So your x-intercepts are negative 2 and 4. For your axis, you're going to take these two numbers and average them together. Negative 2 plus 4 divided by 2. That is 2 over 2, that equals 1. So your axis symmetry is x equals 1. Okay? So those pieces of information, that's going to be questions 1 through 6. Okay? And actually 5 and 6, they don't ask for the axis symmetry, they just want the zeros. Okay, so your zeros here, so x minus 2 equals 0, so x equals 2, x minus 3 equals 0, and that'd have to be a 3. 2 minus 2 is 0, 3 minus 3 is 0. Your axis would be 2 plus 3 divided by 2, so that's 1 divided by 2, so that's a half. So x equals 1 half. This is your axis symmetry. These are your x-intercepts. So it'd be 2, 0, and 3, 0. And they just want the x values. Okay, so you're just going to type in these numbers here. You do not put the points. Okay? The graphing, all of it's just basically matching for you. And so it says match the graph. What I would do, here are questions. It says match the graph x plus 5 times x plus 3. So my zeros have to be negative 5 and negative 3. So I'm looking for a graph that has zeros of negative 5 and negative 3, and it has to go up. Okay, so all of these go up. Negative 5 and negative 3, it looks to be that one right there. So the rest of these questions, that's what you're doing. They're going to give you a function. You look for the zeros, and then see which one matches up with those zeros. Okay, try not to use decimals with this. Try to figure that out. 5 and negative 3 would be your zeros. It's always going to be opposite of what these numbers are, unless you have a number in front. Okay, so that's a lot of these, just matching the graph, and then these last two, write the quadratic function in standard form. So 14 questions with this. If you have any questions, just email me. But I wanted to give you some basic understanding of these quadratics and what they are, and that's it. This is all we're going to kind of do from Chapter 8. I encourage you, if you have some extra time, if you need something to do, go back and work through some other lessons on Chapter 8. You can email me, ask me questions on anything else. Just let me know what section you're on. So I'm going to work through these real quick, but you won't have to do this by hand on your own. So this is x equals negative 5 and x equals negative 1. So negative 1 and 2, 3, 4, 5. Negative 5. There are my zeros. I need my vertex. I need my axis symmetry. So my axis is negative 5 plus negative 1 divided by 2. So negative 6 divided by 2, so x equals negative 3. Again, that's going to be halfway between these. So just 2 units away from each. So this is the x value. My vertex has to be on here somewhere. So negative 3 plus 5, I'm going to take my vertex and plug it in there. Negative 3 plus 1, that is 2 times negative 2. And we get negative 4. 3, 4. So there's my vertex. That gives me a general shape of where the graph should be going. Okay. So this would be 3 and 1. 1, 2, 3. So my axis is 3 plus 1 divided by 2. That's 4 divided by 2, which equals 2. Of course, that's going to be halfway between there. Now you notice when you plug this 2 in, that's just the distance between these. Okay, a minus sign is a distance. So 2 minus 3 times 2 minus 1, all that times negative 4. So negative 4 times negative 1 times 1. And you're going to get positive 4. 1, 2, 3, 4. And it'd go down from there. So domain is all real numbers. Your range for this one is y is less than or equal to 4. The range for this one would be y is greater than or equal to negative 4. Okay, domain is all real numbers. So you get down to this sort of stuff, then you have to start factoring. Once you factor it using that mom method, then you can get you put it into intercept form. Okay? All right. I will see you soon, actually. Today's a Monday. We're having class here in about an hour, so I guess I'll see you in about an hour. Probably not when you're actually watching this, though. So, good luck. Miss you all. Stay strong. See you later.